Hey everyone, this is Mr. Spiels. I'm going to be helping you out with today's lesson. Today's section 11.1, 11.2, arc length and area of sectors. And so the essential question is, how can we find the length and area of a circular arc in a circle? So your exit ticket's going to be on Google Form today. Also, there's going to be a set of practice problems that are uploaded that you can check your answers on with an exit ticket. If you could either have your calculator available or I have Desmos Scientific Calculator up here, so that's something that we've used in the past. If you want to go to that, we can all work through it together. Otherwise, I'll just jump ahead and get us started here. Before we get started, a couple reminders for today that's going to help us in today's lesson is just reminding us what the measure of an arc measure is, or measure of an arc is. The measure of an arc is basically, let's say you have the center of a circle, and let's say you have some angle inside that circle. Okay, let's say it's like this. The measure of an arc is basically the angle that this creates on the inside of the circle. Okay, so like this right here would represent that angle, whatever that is, would represent your arc measure. Okay, so the measurement of the angle that is formed inside the circle when you have an arc. Okay, what we're going to find out today is, and that's a definition that hopefully you learned in the past. What we're going to find out today is, okay, let's say we have this arc measure. How can we find the length of this arc? Okay, I'm not sure my pink highlighter is really showing up very well, but we're basically going to be finding the arc length today. Okay, so that's kind of how it relates to arc measure. Okay, arc measure is the angle. Arc length would be the length of this arc. Okay, the area of a circle, again, I think we've all learned in the past, pi r squared being like the area inside this big circle. Something that we're going to learn today that kind of feeds off of this is something called area of a sector. So what if you don't want to know the area of the entire circle? What if you just want to know the area of this slice right here? Okay, so that's something that we're going to talk about today. And there's equations that we're going to get down for that that you guys can get in your notes and help you through the example problems here. So first, let's talk about arc length. Okay, arc length, like I said on the last slide. And again, if you printed out these guided notes or if you just want to draw this in your notes, arc length is basically the distance from one point on the circle to the other. So in this example, you could have an arc length from A to B, and we're trying to find the length of that arc. Okay? In order to do that, we're going to use the equation, and we're going to set up a proportion. Arc length over 2 pi r is equal to the measure of the angle inside the circle. Okay, arc measure basically is what we talked about in the last slide, over 360. Okay, so it says m is the degree measure of the arc. So in this example, this would be m. Okay, whatever your angle is inside the circle, that is your m. That's your arc measure. Okay, again, that's something we talked about on the last slide. This equation is going to help us find arc length today. Okay, now moving on to area of a sector. Again, like we talked about in the last slide, we know what area of a circle is, but what if we don't want the area of the whole circle? What if we just want the area of a slice of the circle? Okay, what if I just want that area? To get that, we're going to use the formula or the proportion. Area of a sector, so I'm going to write area sector, over pi r squared is equal to the arc measure, okay, so this angle, this measure of the angle inside the circle, over 360. Okay, and if you think about it, these formulas make sense. 2 pi r relates to circumference of a circle, 2 pi r, and we're talking about the distance around a portion of the circle. So that, again, relates to circumference. Area of a sector, you have pi r squared in the denominator, which we've learned in the past that pi r squared is the area of the entire circle. So if we take a proportion of that, we can find the area of a sector. Okay, so that's one way to know the difference between these two equations, because they look pretty similar when you first look at them. Okay, so we're going to use these formulas to work through two example problems. Okay, and these two example problems we're going to do are pretty much going to closely match what you're doing on your practice and your exit ticket today. Okay, so the first one, both of them are going to deal with this drawing down here, the two examples we're doing. The first one says find the arc length of AC. Okay, let's find where that is on the drawing. Here's A, here's C. Now this says arc length. It doesn't say sector area. We don't want to color this in. Arc length is the distance from A to C. Okay, you want to find that arc length. So let's set up our equation. So let's say arc length over 2 pi r. So I'm going to write 2 pi. R represents the radius. Okay, so what is our radius? Well, they're going to give that to you in the problem. Radius is right here. It's 3 inches. Okay, so 2 pi r would be 2 pi times 3. This is your radius. Okay, equals the measure of your arc measure over 360, or the measure of the angle. So angle is 70 degrees. So I'm going to say 70 over 360. Okay, so really, let's just think about this. What we're missing, we have all these values, 73, 62, 2 pi 3. We have everything except arc length. That's what we want to solve for. Okay, so remember we've said in the past when we're solving in proportions, we can cross multiply. Okay, so what I'm going to do is I'm going to go 70 times 2 times 3. Okay, so 70 times 2 times 3 is 420 pi. Okay, again, what I did is I went 70 times 2 times 3 times pi is 420 pi. Okay, I'm going to leave pi the way it is. Okay, is equal to arc length times 360. Okay, so we're trying to find arc length. So if I want to keep this on the right side of the equation, I want to divide out the 360 to get arc length by itself. So if I divide out 360, we're opposite of multiplication is division, so I can divide both sides. Divide by 360. That should give me the answer for arc length. Okay, so let's plug this into our calculator. I'm going to come over here to my Desmos calculator, and I'm going to say 420, here's pi. Okay, if you don't know where pi is on your calculator, if you have one of these blue scientific calculators, pi is right here. Otherwise, if you have a graphing calculator, it's usually on the right side of the graphing calculator. So I'm going to say 420 pi divided by 360. Okay, and what's that going to set us equal to? That's going to set us equal to, we're going to round to 2 decimal places here. So let's say 3.67 is equal to my arc length. Okay, so 3.67 is my arc length. Okay, so again, just to recap, I cross multiplied, but I left pi. I left it in terms of pi. Okay, 70 times 2 times 3 is 420, and I put the pi right next to it. Okay, and then I cross multiplied on the other side. Arc length times 360. I divided out the 360 on both sides and got 3.67 as my arc length. Okay, all right, let's try one with area of a sector. So it says find the area of the sector formed by angle ABC. So let's find that angle, ABC. Okay, so here's our angle. Looks like we're going to have to find the area of the sector that's shaded in by this region. Okay, so to do that, we're going to go back to our formula. We're going to say area of a sector over pi r squared is equal to the arc measure, or the angle inside the circle, over 360. Okay, so let's start plugging some things in. I'm going to say area of a sector, which is what we're going to solve for, over pi r squared. Well, r is my radius, so I'm going to say 3 to the second, okay, is equal to, here's my angle, 70 over 360. Okay, now again, we're going to cross multiply, and so here what you're going to have is 3 to the second is 9, so I'm cross multiplying this way. 3 to the second is 9 times 70. Let's do that in our calculator here. Clear out. 9 times 70 is going to give you 630, so that's going to be 630 pi is equal to area of the sector times 360. Okay, because remember, we're cross multiplying this way, area of the sector times 360. So if I divide out the 360, okay, that should give me my area of a sector. Okay, so that's what I'm going to do over here. I'm going to say 630 pi divided by 360. And that's going to give me, let's again round, and I'm going to round it again to 2 decimal places. So this is actually going to come out to 5.499 would round up, so it'll be 5.50 equals your area of a sector. Okay, so all your problems in your practice today are just going to be using these two proportions, and let me go back to them. Arc length and area of a sector. Set up your proportions, cross multiply, and solve. You're either solving for arc length or you're solving for area of a sector. Okay? Hopefully this helps. Just reach out to your teachers if you need extra assistance.